In this video, we're going to be talking about electrical safety and wiring. Okay, now safety plays an important role with anything with electricity. You do not want to hurt yourself or someone else because of things not being wired properly, tools not being used correctly, and basic safety precautions not being followed. So as with any of our courses, we're going to start off with a little conversation about safety. Okay, first of all, never assume a system is off. You want to check all circuits before beginning work, and you want to lock and tag all electrical disconnects before doing service work. Now, this also applies for your work in our shops. Okay, it's a basic safety precaution. Make sure the circuits are off or powered and you know that they're powered. Remove all jewelry, rings, watches, and chains. Never bypass an electrical safety device. Watch yourself and those around you. You do not want to accidentally get pushed into a live circuit. Don't work on live circuits except absolutely necessary. Stand on dry, non-conductive surfaces when working on a live circuit and using electrical tools. You know, it doesn't do any good to have rubber-soled shoes, do all your lockout, tag outs, be careful with your meters if you're standing in a water puddle. Okay, check all circuits for voltage before doing service work. Don't underestimate the potential danger of electricity. Don't use tools with damaged or frayed cords, and always wear eye protection. Eye protection is important because there's some components in our circuits that we work with that have a real possibility of exploding and putting dangerous chemicals in your face. When adjusting power tools, be sure to unplug them. You don't want to lose a finger if you accidentally hit the start button on a drill. Don't overload electrical circuits. They're only meant to take so much load, okay, and sometimes breakers don't pop soon enough. Don't work alone if possible. Now, this is not reality in the field. You're going to work alone 9 out of 10 times as a service technician. But, you know, there's a solution to that. Always let your service dispatcher know if you're getting into a situation that might not be 100% safe. Be careful when using screwdrivers on electrical panels. One slip, the screwdriver could be inside the panel in a hot part of the circuit. And you want to learn first aid. Voltage is not what's going to kill you, it's current. The human body has resistance. If voltage is applied, current will flow through the human body. Okay, here's an example, okay? You've accidentally touched a short-circuited frame of a furnace. You become part of the circuit because the voltage is going to take the easiest path to ground, or the current's going to take the easiest path to ground, which might be you. Okay, so always check what you are doing and how are you doing things, okay? I mean, it's usually not a good idea to hold a power tool that's plugged in and be touching a grounded water pipe. By the way, most copper pipes in houses are the grounding for the house, okay? If you have a path between line 1 and neutral, if you touch both terminals at the same time, you become part of the circuit. A screwdriver that you're using near a circuit, it's very possible to get sparks flying and you become part of the unit and circuit. Okay. Once again, you touch an L1 and L2 at a junction box without realizing that the circuit is on. If you've used both hands, the current is going to flow directly through your heart. Okay, a current of 2 to 3 milliamps is going to cause a tingling sensation. The tingling sensation increases and becomes painful at about 20 milliamps. Currents between 20 and 30 milliamps will cause muscle contraction. At 20 and 30 milliamps, you might be unable to let go of the circuit. Okay, it's going to catch your muscles and force you to hold on to the circuit. Currents between 30 and 60 milliamps will start causing muscle paralysis and difficult breathing. Currents at 100 and 200 milliamps can generally cause death. One of the best ways to prevent electrical shock is to use lockout tagout. Equipment being worked on should be disconnected from the power source and locked. Okay, this is an example of a lockout tagout kit. Basically, the little lockout device on the left-hand side goes on the disconnect or the breaker or the switch. The tag gets hung on with the lock. The back side of that tag shows who did it and why. Okay, multiple panels can be locked out in the same method. If you have more than one technician working on a piece of equipment, they each put their own lock on it. The person working on the equipment should carry the only key. This prevents accidental re-energization of the equipment. The lockout tag has the name of the person working on the equipment, what service is being performed, reason for the service, and the date and time. When you're using ladders, we want to use non-conductive ladders. Okay, you don't want to use metal or aluminum ladders. They can be hazardous. Non-conducting ladders are made of fiberglass or wood. Now be careful with wood ladders and make sure they haven't become loose and unstable. But fiberglass and wood ladders will prevent you from shock to ground in case you get into a live circuit. Electrical tools with metal frames should have a grounding cord. That's 3 prongs on the outlet. That grounding wire will protect you from an electrical shock if something goes wrong inside the hand tool. The grounding adapter must be connected to a good ground. Okay, you'll notice again, this drill has 3 prongs on the outlet. Okay, and this drill only has 2 prongs because this drill has a plastic frame. Try to use 3 prongs whenever possible. The ground wire provides an alternate path for electrons to travel to ground instead of through the person's body. It will also let a breaker or fuse trip to the circuit. It only carries current in the event of a short circuit. The ground should always have a 0 voltage potential. It's connected to the frame of the motor or appliance. In other words, it's not always part of the circuit, nor should it be. Ground wires are required by the NEC code on all electrical systems. Most often, the color for this wire is green or it's a bare copper wire. The ground wires are connected inside the breaker panel and then to a solid copper rod driven at least 8 feet into the ground. The copper rod is called a grounding electrode. It completes the neutral wire is also found. Most often, it's a white wire. Okay, it completes the path for current in a 120 volt circuit. It has 0 potential to ground. In other words, they're bonded. It's not to be confused with the ground wire. The neutral wire connects at the same terminal as the ground wire at the service panel, nowhere else. The neutral wire is connected to the transformer on the street and to the earth. It provides the other half of the 120 volt circuits. The earth always has a 0 potential, no voltage. Okay, so many electrical devices operate with just one hot wire and a neutral. A potential difference exists between the hot wire because the hot wire has voltage. The neutral wire has white insulation for ease of identification. The hot wire usually has black insulation. It can be another color. It can also be any other color except white or green. A 120 volt reading will be found from the hot wire to neutral or ground. Now, occasionally that number is over 120 volts, but it's nothing to be concerned about as long as it's not up in the 240, 300 volts category. Okay, so this is an example of a breaker panel and a power distribution system. We start off with the street, okay? It's close to 23,000 volts at the street. Drops down to an L1, L2, and a neutral at the transformer to the house. Okay, comes in at 240 volts between L1 and L2, or 120 volts between L2 and neutral. Okay, neutral is actually connected to ground in the breaker panel. There should not be any voltage difference from neutral to ground. And that completes our presentation on safety and basic electrical wiring. Now again, the importance of this is that you are always aware of what you are touching in a panel, where to expect voltage on your power feeds, and the importance of ground and neutral.